Every star you see in the night sky is dying. Some will survive for trillions of years. Others will explode in just a few million. But every one of them begins the same way, burning through their fuel so quickly that they live only a few million years before exploding. Yet despite these enormous differences, every star begins in exactly the same way. Inside vast clouds of gas and dust, known as stellar nurseries. Some of these clouds stretch for hundreds of light years and contain enough material to create millions of stars. Over time, gravity slowly pulls the gas together. The cloud becomes denser, hotter, and eventually, a protostar is born. At first, it isn't a star at all. It's simply a growing ball of gas, but deep inside, something extraordinary is about to happen. The temperature rises above 10 million degrees Celsius. Hydrogen nuclei begin to fuse together, and for the first time, a star ignites. A new sun is born. From this moment on, gravity tries to crush the star inward, while nuclear fusion pushes outward. For billions of years, these two forces remain in perfect balance. This is the longest chapter of a star's life. Astronomers call it the main sequence. Our own sun is here right now, and it has been for nearly 4.6 billion years. But no star burns forever. Eventually, the hydrogen fuel begins to run out, and when that happens, everything changes. The star's core contracts, its outer layers expand, and it transforms into a red giant. Our sun will one day become so large that it may engulf Mercury and Venus. Some calculations suggest Earth itself could be swallowed. Even if it survives, its oceans will boil away long before then. But for larger stars, the future becomes far more violent. Massive stars can grow hundreds of times larger than the sun. One of the largest known stars could fit billions of suns inside its volume. These cosmic giants burn fuel at an incredible rate, and because of that, they die young when their cores collapse. The result is one of the most powerful explosions in the universe. A supernova. For a few brief moments, a single dying star can outshine hundreds of billions of others. Brighter than an entire galaxy. The explosion releases more energy in seconds than our sun will produce during its entire lifetime. The elements created during these explosions become the building blocks of planets, ocean, mountains, and even life itself. Every atom of calcium in your bones and much of the iron in your blood was forged inside ancient stars. In a very real sense, we are made of stardust, but a supernova is not always the end. What remains depends on the star's mass. Some leave behind white dwarfs, objects roughly the size of Earth, containing nearly the mass of the sun. A teaspoon of white dwarf material would weigh several tons. Imagine holding something no larger than a spoon, yet heavier than a truck. But even white dwarfs are not the most extreme objects in the cosmos. Others become neutron stars, the collapsed cores of dead giant stars. These objects are so dense that a single teaspoon of their material could weigh more than 1 billion tons. A mountain compressed into something that could fit in your hand. Inside these stellar remnants, matter exists in ways that seem almost impossible. Atoms are crushed, electrons and protons merge, and what remain is an object unlike anything found on Earth. Many neutron stars spin hundreds of times every second, creating beams of radiation that sweep across space like cosmic lighthouses. As they rotate, those beams flash across the universe again and again and again. Yet even neutron stars are not the ultimate limit. If enough mass remains after the collapse, gravity wins completely. The star disappears, not because it no longer exists, but because it becomes something even stranger. At this point, the battle is over. Gravity wins completely. A black hole, a region where gravity is so powerful that not even light can escape. No signal, no message, no warning. Everything that crosses the boundary is lost to the outside universe. Some black holes contain the mass of dozens of suns. Others, lurking silently at the centers of galaxies, contain billions, invisible, silent, and unimaginably powerful. Yet not every object born from a stellar nursery becomes a star. Some never gather enough mass to ignite fusion. These failed stars are known as brown dwarfs. Too large to be planets, too small to be true stars. They glow faintly from leftover heat, slowly, incredibly slowly, cooling for billions of years. Neither planet nor star existing in the strange boundary between the two. Meanwhile, another type of star quietly dominates the universe. Red dwarfs, small, dim, and easy to overlook. Yet nearly 3/4 of all stars in the Milky Way belong to this category. Unlike massive stars, they burn their fuel incredibly slowly. Some may continue shining for more than 10 trillion years, which means none have died naturally yet. The universe simply isn't old enough. Think about that. Entire civilizations may rise and fall, mountains may disappear, galaxies may collide, and these stars will still be shining, patiently, silently, waiting, from tiny red dwarfs to giant stars capable of creating black holes. The cosmos is filled with extraordinary destinies, and yet every one of them begins the same way. A cloud of gas, a collapse under gravity, a spark of fusion, a new star. Right now, somewhere in the observable universe, thousands of stars are being born every second. Others are dying, and countless more are somewhere in between. Their stories unfolding across millions, billions, and even trillions of years. Every flash of light, every distant star, every glowing point in the night sky is part of a story far older than humanity itself. So the next time you look up, remember this: every star has a story. Every point of light is a different chapter. Some are just beginning, some are nearing their end, and some died long ago, their final light only now reaching Earth. Because when we look into space, we are also looking into the past. But perhaps the most fascinating question is this: if stars have life cycles, where exactly is our sun in its own story, and what will happen when it reaches the next chapter? Welcome to the dark universe.